Okay, good morning, guys. Welcome back to week 2 of partial 4. Today, we're going to start with a new topic, one of the very last of graphing. And as usual, first, we're going to start with some theoretical part. The first definition that we're going to see is system of linear equations. What is the system of linear equations? Well, a system of a linear equation is formed by two or more linear equations. And these linear equations are graphed in the same coordinate plane. We will be working with only two equations in a system, meaning that we're going to have only two variables as well. We're going to see how to solve these systems in different ways. The first one is by graphing, and we're going to see how it is graphed and how many solutions it has, okay? We have three possible solutions in any of the types of solving systems of linear equations, okay? So we have one solution when there is exactly one order pair that will make true both equations, or in other words, when the graph of two lines intersect in one point, okay? In one specific point, in one exact point. And that point is the solution of the system. So let's say that you graph the two lines, okay? And they intersect like that. So this exact point in here, in the right where they touch, where the two lines touch, that is a solution. So you say that it has exactly one solution. Infinitely many solutions is when the graphs of two equations are exactly the same line, meaning, in other words, that all of the points on the line are the solution. So you go ahead and graph the first line, and by any coincidence, the second graph goes right on top of the first one, okay? So every single point of your line is touching. Why every single point? Remember, a line is made out of a lot of points connected one next to the other, okay? All of those points, if you have the same line, will be exactly the same points for the second line, just like that, okay? It will be exactly the same line. So that's why it's called infinitely many solutions, because any point of that line, any order pair of that line will make true the second line, okay? And no solution is when the graph of the two equations are parallel. We already know how to identify parallel lines. Remember, parallel lines have exactly the same slope, okay? So they're like this, or like this, or like this, or completely horizontal. It doesn't matter how, as long as you're parallel, it means that there is no point of intersection. This line will never touch, will never intersect this second line, never. They will extend to both sides, having exactly the same distance in between them, okay? So they will never, ever, ever, ever intersect. Therefore, there is no solution, okay? You're gonna see how we determine that there's no solution when we are solving a system with the other method, okay? Now, again, we have three types of solutions: one solution, infinitely many solutions, or no solution, okay? Now, let's do our first exercise. So we are going to have an easy one, okay, a very easy one. And we're going to start off with, let's go to the book. We're going to see exercise 9, okay? So exercise 9 from your book, this is page 343, okay? This is exercise 9. Exercise 9 says, y is equal to negative 1/3 x plus 1, and y is equal to positive 1/3 x minus 3. Okay, so we already know how to solve systems. So we're going to solve equations, how to graph them. We're going to call first this equation, equation 1, and we're going to call this equation, equation 2. Why do we do that? So we can find the intercepts. That's the method that we will be working with, the method of the intercepts of each equation. And then we're going to graph it, okay? So we're going to go with equation 1. Y is equal to negative 1/3 x plus 1. Now remember, intercept in x is when we're looking for x and y is 0. So we have 0 is equal to negative 1/3 x plus 1. Since this is negative, I'm going to pass it to the other side to make it positive so I can have the y by itself. Okay, I'm going to go higher. And we're going to have 1/3 x is equal to positive 1. Now, this is a fraction that's multiplying, and this is the only case where I don't use an inverse operation. I continue to multiply, and I flip. Okay, remember that. When it is a fraction multiplying, you continue to multiply, but you flip. So this is x is equal to 1 times, instead of 1/3, 3/1. So x is equal to 1 times 3, 3 over, and I copied the denominator. Okay, remember the little trick. Do I need a denominator 1? No, right? So I don't write it. I'm going to place here 3. Now I'm going to find the intercept in y. And that is when x is 0. And I'm looking for y. So y is equal to negative 1/3 times 0 plus 1. 3 times 0, that's 0. So I have left only the 1. And that is my first line, the green one. Now I go with the equation 2. I'm going to do it in the procedure in black, but I'm going to graph it in blue, okay? So equation 2, same procedure for the intercepts. Y is equal to 1/3 x. Remember, if you have questions, you let me know. You can either open your microphone or just type it on the chat. Okay, so the intercept in x, when we're looking for x, but y is 0. So 0 is equal to 1/3 x minus 3. Now pay attention to what I'm going to do here. In this exercise, of the first one, in the green one, in equation 1, I decided to move the x with its coefficient to the left because it was negative. So I made it positive. In this other case, it's already positive. So which I'm moving, the term that I'm moving is the constant. Okay, because I want to leave the variable x completely positive in one side. In this case, it is already positive on the right, so I leave it there. In this other case, it was negative on the right, so that's why I moved the variable. Okay, you can move whichever one you want. If you move this, it will go negative. It doesn't matter. At the end, you're going to have the same answer. I just try to skip a step. Okay, so I'm moving the 3. It goes positive. 3 equals to 1/3 x. And just like we did in here, the x is, the 1/3 is multiplying. It is a fraction, so it continues to multiply, but I'm going to flip the fraction or reverse it, okay? So I'm going to have 3, this 3, times, instead of 1/3, 3/1 equals to x. 3 times 3, that is 9. Over 1, I don't need the 1, so I'm going to say 9 is equal to x. And that's the 9 that I'm placing over here. Now I go with the intercept in y. When x is 0, and I'm looking for y. So I'm going to say y is equal to 1/3 instead of x, 0 minus 3. 1/3 times 0, that's 0. So I got left that y is equal to -3. and that is my intercept. Okay, I got it, done. Now I just need to graph it. As you can see, I need x9, and the biggest one that I need on y is +1 and -3. So it could be small from the y's and a little bit longer on the x. -1, -2, -3, +1, +2, -1 on the x, -2, +1, +2, +3, 4, 5, 6, 7, 8, 9. I'm gonna make it a little bit longer. Two, 3, 4, 5, 6, 7, 8, 9. Okay. I'm gonna graph this one in green. And I'm gonna graph this one in blue. Okay, the green one. 3, 0, 1, 2, 3. And 0, 1. Over there. I'm gonna connect those 2 points with a straight line passing through the center of both. We saw this already. And I'm gonna extend it a little bit longer, okay, to one side. Actually, to both sides, okay? I'm gonna make the arrowheads. Now I'm gonna graph the blue one. It says 9, 0, so it's over here. And 0, -3, -1, -2, -3. I connect those two with a straight line passing through the center of them. And I extend it a little bit more. And I draw my arrowheads. Now, question is, those 2 lines, do they intersect in one point? Do they touch each other in one specific point? Yes or no? Do they intersect at a specific point?
Yes.
Yes, they intersect right there. Okay, so it has one solution. Okay, it has one solution because they intersect in one point. And what is the solution of this? Okay, let's look and find the order pair for that point. Okay, so since the graph is not completely perfect, the point slightly to one side, but apparently it is 1, 2, 3, 4, 5, 6, 6, comma, -1. So the solution, one solution is 6, comma, -1. How do we prove it? Okay, we're going to prove it just for this exercise. For our classworks or homeworks, you are not going to be in need of proving this, okay? But for right now, for you to know the proof, how do I prove it? I need to substitute this. Remember, this is x and this is y. I need to substitute it inside of both equations, and both equations need to be true. How do we know that an equation is true? Because one side is equal to the other side. That's how we know it is true. Okay, like 0 equal to 0, 3 equals to 3, -4 equals to -4. If you got that, then yes, it is a solution of the equation. If you get 6 equals to 5, it is not true. Something is wrong, okay? Maybe you didn't copy the order pair correctly. So let's do the proof for the first one. Y is -1 equals to -1/3 times 6, because x is 6, plus 1. Okay, so -1, there's nothing to solve on that side. Now we solve this. -1 times 6, that's -6 over 3 plus 1. -6 over 3 can be simplified to what number?
-3.
Nope. -6 divided by 3 is how much?
-2.
-2 plus 1. We can still simplify on the right. So -1 is equal to -2 plus 1. -2 plus 1.
-1.
-1. Is -1 equal to -1?
Yes.
So it is true for the first one. It has to be true for both of them. Okay, let's go with the next one. Again, y is -1 equals to 1/3. X is 6 minus 3. So -1 is equal to 1 times 6, that's 6 over 3 minus 3. I don't have to solve anything on the left. 6 divided by 3,
2.
positive 2 minus 3. Positive 2 minus 3.
-1.
-1. Is -1 equals to -1 in here?
Yes.
So it is true on both. So yes, we know that this is correct. We do have one solution, and the solution is the order pair 6, comma, -1. And that's how we solve a system by graphing. Questions? Let's do another one. I'm gonna do it over here. I think we can make it smaller. There was no need to have it that big, okay? So I'm gonna make it smaller so I can have more space on this side. Okay, next exercise, I'm gonna copy the exercise in block. We are doing exercise number 16. Exercise 16 says x plus 2y equals to 10, and 2x plus 4y equals to 10 as well. Okay, step 1, choose equation 1 and choose equation 2. This is equation 1 in blue, and this is equation 2 in green. And I'm going to find the intercepts for each one of them. Okay, x plus 2y equals to 10. Okay, intercepting x for this one. When y is 0. So we go ahead and say x plus 2 instead of y, 0 equals to 10. 2 times 0 is 0. So x is equal to 10. That's the 10 that I place over here. Now the intercept in y. When y, x is 0, we look for y. So we got 0 plus 2y is equal to 10. I don't need this 0, so I can say 2y is equal to 10. The 2 is multiplying, passes to the other side, dividing. Okay, and we have that y is equal to 10 over 2. How much is y, 10 over 2?
5.
Okay, very good. And I finished the first one. 10, 0 and 0,5. Now for equation 2, we do exactly the same thing, exactly the same thing. So we got 2x plus 4y equals 10. Okay, so intercepting x, we got 2x plus 4 times 0 equals to 10. Cancel out that one. So I have 2x is equal to 10. 2 is multiplying, passes dividing. So x is equal to 10 over 2. And again, the answer is 5. In this case, it's 5, 0. Let's do the other one, the last one, the intercept in y. This is 0, something. So we got 2 times 0 plus 4y equals to 10. 2 times 0 is 0. I have 4y equals to 10. 4 is multiplying, passes dividing. So I have the y is equal to 10 over 4. Can I simplify 10 over 4? Can I simplify 10 over 4? I can simplify by 2. It is not an exact solution, but I can simplify it by 2. So I have 10 divided by 2, that's 5. And 4 divided by 2, that's 2. So this is the 5/2 that I'm going to use. And just for purposes of graphing, I'm passing that to a decimal. So this is 0, how much is 5 divided by 2?
2.5.
2.5, very good. Okay, as you can see, we do need a lot of numbers because we need a 10, okay, and 5 on the y's. So 10 on the x and 5 on the y, all of them are positive. So I can just go ahead and do the positive ones in here. There. So 1, 2, 3, 4, and 5 on the y. And I need 10 on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're erasing the rest. Okay, let's go with the blue one. Okay, the blue one. 10, 0, so it is this. And 0, 5. 1, 2, 3, 4, 5. I connect those two, passing through the center with a blue line. I extend it a little bit to both sides. Now I go with the green one. 5, 0. 1, 2, 3, 4, 5. And 0, 2.5. 1, 2. 2.5 is right in the middle in there, between 2 and 3. I connected with a straight line passing through the center of both points. You use a ruler. I extended a little bit to both sides. And how many solutions do I have? How many solutions do I have, guys?
No solution.
No solution. Why, Natalie?
Because there's no point that they intersect.
There's no point that they intersect. Why? What type of lines they are?
Parallel.
They're parallel lines, so we got no solution. Okay, and that's the second type of solution that we have. Okay, any questions? No questions? Okay, so extra point exercise for you. I will be opening This will be your first extra point exercise. We're going to call it extra exercise. Solve exercise 17 on same page, 343 of your textbook. Solve it, okay? You need to solve it just like we did and tell me how many solutions it has. No solution, one solution, or infinitely many solutions, okay? Now let me see. Let me see if I want that one. Yeah, it could be that one. This is lesson 7.1. So number 17, that's fine. Yep, that's the one that you're gonna do. Number 17. Questions? No? Okay, this is everything for today.